Hello and welcome back. So, as I mentioned, part of your homework will be to do Lesson 1 in Set 1, number 15. And also, please do Lesson 1, Set 2, all the problems there. They'll help extend upon the investigation we did in that first part. So let's go ahead and move on. And now if you'll turn in your textbook to Lesson 3 on page 19. And pause the video at this time and read the introduction to Lesson 3. Hi and welcome back. We should have read the introduction to Lesson 3. Lesson 3 is discussing inductive reasoning, and what that is moving from the specific to the general. This is otherwise known as generalizing. A scientist may make some observations and then create a general hypothesis based on those observations. We do this all the time in our daily lives. Well, let's see how it applies to math. Well, if we take a look at the equations below, we begin to see what appears to be a pattern. Okay. So if I take the number 1, I can say that's equal to 1 times 1, or 1 squared, and it is. If I take 1 plus 3, which is the next odd number, I get 4. And I could say that's equal to 2 times 2, which also is 4. If I continue on the pattern of adding odd numbers and then moving along with the square numbers that you see in the middle column there, you'll notice that they are equal. So 1 plus 3 plus 5 is 9, and 3 times 3 is 9. 1 plus 3 plus 5 plus 7 is 16, and 4 times 4 is 7. So when I add up the odd numbers in this pattern, I should get that equivalent square number. So let's see if this pattern holds true. So what is the next equation in the pattern? Well, it would be to add the next odd number, which is to add 9. And when I do that, I get 5 times 5, which is 25. So the pattern holds. Well, let's keep going. What about the 7th number, or the 7th equation? The 7th equation would be to add 11 and 13, and that is equal to 7 times 7, which is 49. So the pattern continues. Let's keep going. What about the 10th number? If I look at the 10th equation and I add that up, it does equal 100, and 10 times 10, or 10 squared, is 100. So the question is asked, does this pattern go on forever? What do you think? Well, based on what I see here, using inductive reasoning, I can conclude that it probably does go on forever. I don't know that for sure, but it would sure seem to be. And I could test it and continue to test it to prove that that be true. That is inductive reasoning. So for homework, what I'd like you to do is in Lesson 3, do Sets 2 and 3, all the problems. And they will allow you to apply this idea of inductive reasoning. So let's talk a little bit more, though, about inductive reasoning. There are limits. Sometimes you cannot go from the specific to the general, or it will only go so far. Let's take a look at these numbers that are here on the slide. We have 31, 331, 3,331. You see the pattern. We keep placing a 3 in front. Well, these are all prime numbers. A prime number is a number that is only divisible by 1 and itself. So what about the next number in this pattern? Well, the next number in the pattern is right there, 333,333,331. All right, so our inductive reasoning would tell us that this is also prime because that's the pattern that we found. However, if we divide this number by 17, it actually divides in evenly. Therefore, the number is not prime. So here, inductive reasoning did not work at all. So that is a limit to inductive reasoning. Let's talk about deductive reasoning. Deductive reasoning is a method of using logic to draw conclusions from statements that we accept as true. So it goes from general rules to specific instances. We can take a rule and apply it to something specific. These statements we accept as true are math rules. Those are our general rules that we apply to problems. So, for instance, if 3 plus 1 equals 4, then 1 plus 3 has to equal 4 as well. That is a math rule. So, remember the mind reading trick that I did in my opening message to you. Why did it work? Because it worked on all of you, I'm sure. Well, the reason it worked is I used math rules. It's very deductive. I took the number that you guessed, and what did we do? We multiplied it by 9. Well, in doing so, I then asked you to add the digits together. And if you notice from the chart here, all the digits, when you add them together, always add to 9. Okay, that's because that's a math rule that works out that way. So then when I ask you to subtract 5, we always end up with the same number. It just works out that way. So this allows this to work. The rules of math allow this mind reading trick to work. So when you try to do this trick for your friends at parties or things as such, you can amaze them, but don't tell them that it always works, because you don't want to give away that you're not a mind reader. So when you came up with the number 4, the letter associated with that was D, and there's only one state that starts with D. It's designed that way so everyone will have to guess Delaware, unless of course they don't know what the 50 states are. Therefore, we applied this arithmetic rule for the trick to work. I want to thank you for watching part 1 of this lesson. Please go ahead and now watch part 2, where we will talk about mathematical problems.